Okay, continue with lecture 9, real zero of polynomial. Before we talking about real zero, let me recall some of the division. First of all, your least favorite, long division. Oh, the good news is you don't have to know long division for this exam. So if you're good at long division, good for you. If you're not, don't be nervous because it's not required for this exam. Right? But what you need to know is synthetic division. Do you guys remember synthetic division? It's a shortcut of long division. The only drawback of synthetic division is that it only works if your divisor, the one in the denominator, has the form. Oops, too dark. It only works if the divisor, I denote the big D of x, has the form either x plus h or x minus h. It's only work with linear divisor, right? And then the coefficient of x has to be 1. That's a drawback. If it quadratic in the denominator, you cannot use synthetic division or any other degree other than 1. Long division works for everybody. It's just long. So another way to simplify your rational expression, when I say rational expression, I meant p of x over d of x, whereas your p of x and d of x are your polynomial. Pull up my notes from last night so I can see the views right. So I'm going to start out at p of x. Say p of x and d of x are polynomial. Of course, d of x cannot be 0, otherwise you run into undefined problem, right? The degree of the divisor, big D of x, is less than or equal to the degree of the numerator, p of x. Right? It has to, otherwise you won't be able to perform synthetic or long division. If I have p of x on the top, that's my numerator polynomial, divided by d of x, usually it's going to be a linear divisor. Then my answer, I'm going to have a quotient by denote q of x plus r of x, which is your remainder, divided by d of x. Do you guys remember this from 661 at least? Right? When so for example, I'll give you an example here. This is an example. Example, if I take 5 divided by 3 equal to what? 5 divided by 3 is 1, and then remainder will be 2, right? So if you were to write it in form q of x plus r of x divided by d of x, you would write like this. It's going to be 1, which is your quotient, your q of x, plus the remainder, which is 2, divided by the divisor, which is 3. Does that make sense? That's what they meant by rewriting in that form. In the case it will remainder is 0. If r of x is 0, 0 divided by anything is 0, right? So we don't have to write the fraction if your remainder is 0. This is for checking result. If you multiply d of x, if you take the divisor, multiply back to the quotient, which is your answer, plus the remainder, it should get back to the original numerator. Right? It's not important for this class. What important is this one, that one. Well, terminology here, p of x is called dividend. D of x is the divisor. Q of x is your quotient. And R of x is the remainder. are some notes. The degree of the remainder should be either 0. When the degree is 0, that means what? It's just a constant, right? The remainder is just a constant because actually 0 is 1. Or it has to be less than the degree of the divisor. If the remainder is 0, means what? You divide things evenly, right? All right, let's take a look at 1B. I'm gonna, for long division, since it's not required for this exam, you can take a look at on your own, but I'm gonna go ahead and use synthetic division for this one, okay? This one right here. So first, I'm gonna write out my coefficient. Every single coefficient. If you have a missing coefficient, say hypothetically, I don't have this term. Say hypothetically, I don't have negative 3x squared, then you will replace the coefficient of x squared by 0, right? So you gotta write out every single coefficient of every degree. In this case, we have everybody here, so we don't have to replace 0 with anyone. So 2, negative 3, 4, 5. And then to the left, you draw a little box. How do I? The box will be your 0. When I say zeros, meaning one of the solution of the problem. Your divisors, you're gonna set your divisor equal to 0, meaning you set x plus 2 equals 0. Subtract 2 both sides, x equal negative 2. So that what you're gonna put in your box. Basically, whatever you see there, just put the opposite number in the box. Does it make sense? And then the first step, you're gonna take down the 2. Always bring down the first coefficient. And then you take 2 times negative 2. 2 times negative 2 is negative 4. And then you add down. You add down. So negative 3 plus negative 4, that's minus 7. And you do the same step. Negative 7 times back to negative 2 in the box. I have positive 14. 4 plus 14, that's 18. Same step. Multiply back to the one in the box. 18 times negative 2 is negative 36. Add down, or use blue. Add down what you got. You got negative 31. Did I make any mistake here? Huh? Negative 4. Negative 2 times negative 2 is negative 4. So negative 7, positive 14, 18. I think I'm okay here. Now, your last number in your answer, your last number always, that's your remainder. Always your remainder. So negative 31, that's all that. And your quotient would be this one. That's your quotient. That's your Q of x. And how would I write Q of x? You're gonna start from left to right. I'm sorry, from right to left. So the 18 will be the constant, right? And then negative 7x, and then 2x squared. And that's, you go 1 degree up from right to left. Yeah. So 18, that's your constant, and then you go 1 degree up. Negative 7x, and then 2x squared. What's the degree of 18? For what the, if I don't, I know I don't write it, but if you understood it, 18 basically is 18 times x is 0, right? That's why you go 1 degree up, right? 0 degree, first degree, second degree, right? But we don't ever write x is 0 because it's always 1. Am I finished my answer? No, right? You're gonna write it in this form. Remember this form. Remember what I said, that form, right? So since you have a remainder, you're gonna add to it. So plus negative 31 divided by the divisor, which is, what's the divisor here? x plus 2, right? Not negative 2, x plus 2, the original divisor. And that will be your complete answer. So far, so good. I know I talk a lot, but it's not hard. It's when you do on your own very fast. Why don't you guys try number 2? So I'm gonna write down my coefficient, 5, 3, negative 2. There's nothing missing, so I'm okay. And the box is gonna be opposite for what you see. So negative 1. Bring down the 5, always bring down the 5 first, the first coefficient. And then you take the 5, multiply to the box. So negative 5, add down, negative 2, multiply back, positive 2, 0. By the way, the reason we switch the sign for the number in the box so that you just add down instead of subtract. It's easier to add than subtract, right? Especially you have multiple negatives. If you keep it 1, it's not wrong, but instead of add down, you're gonna subtract down. Right? But just let's switch it. It's just easy. So that'll be 5. Someone tell me the answer. -2. And then that's it, right? Because the reason you don't write the form, because 0 divided by x plus 1 it's going to be 0, right? So I'll leave it like that just for the sake of the note. But you give me the answer, that's fine too. It's the same thing. Okay, so I assume everybody okay with synthetic division? That will prepare you for the exams. One of the problems that find the zeros. Now another way to simplify this besides long division and synthetic division is by factoring. Factoring is one of the things that you just, if you keep taking math classes, you always see it. It's always there till like even grad school. So let me rewrite the problem using factoring. 5x. So I'm just rewriting this. Plus 3x minus 2 divided by x plus 1. I'm gonna, it's not important for this lecture. It's not factoring lecture, so I'm gonna use guess and check method. Can you find two number multiply to 5x squared? 5x and x, right? That's all. That's only one option you have, right? 5x and x. And then I'm not caring about the middle term yet. And then the negative 2, it's gonna be negative, it'll be negative 1, positive 2, right? Something like that. Where do I put the negative 1, positive 2? Let's guess and check. I'm gonna put a negative 1 here. Just write this down. And positive 2 here. So I'm gonna check. Now, the first and last check, right? 5x times x is 5x squared, and then negative 1 times positive 2 is negative 2. Well, I gotta check for the middle term. For the middle term, you're gonna check for the inner and outer. Remember, FOIL. O is outer, I is inner, right? So negative 1 times x is negative x. And then the outer 5x times 2 is 10x, which is not 3x, right? So you switch it around. That's why they call guessing check. So you know that you might have to put the -2 here and the +1 here. And I think now it's check, right? -2x for inner and +5x for outer, add up to +3x, right? But it's not important. And then bring down the divisor. And then you can cancel that. So you have 5x minus 2. Same answer you do in synthetic division. Just for comparison, your focus is synthetic division. All right, let's do some more synthetic division. They want you to find the remainder when p of x is divided by x minus 1. So that means they ask you to perform synthetic division. So I'm going to write down my coefficient here. -9, 10, 7. I'm missing 1 degree, so I'm going to replace, I'm missing an x, right? So 0 or x, and then -6. In the box is going to be 1. In the box, only 1. Bring out the -9. -9 times 1, -9. 10 plus -9 is 1. 1, 8, 8, 8, 8, -2. So what you got? So -2 is your remainder. Oh, +2. Thank you. Sorry about that. Thank you. +2 is your remainder. So I have negative, let's see, so 8, 8, and then 8x, I always do it from right to left, and then x squared, or 1x squared, and then -9x cubed, plus 2 over x minus 1. Does anyone have a question why I'm writing like this? Okay, all right, good. For part B, I want to evaluate. Did I make a mistake again? Let me double check. 9, 10, 7, 0, -6, -9, -9, 1, 1, 8, and then 8, 8, 8. Why would they say evaluate P of 1? Oh, yeah. Evaluate P of 1. 1 is your the one in the box. So P of 1, evaluate P of 1. Basically, you plug in 1 for x, right? One. All right, everything 1 is just going to be 1, doesn't matter. So -9 plus 10 is +1, plus 7 is +8, minus 6 is 2. Yeah, everything is yes. Because original, it given P, right? P of x. P of 1 to plug in that function. What do you think? What do you think about number 2 on the right, and then the remainder on the left? They're equal, right? They're the same. So that's called the remainder theorem. If the polynomial P of x divided by x minus r, then the remainder is the value of P of r. That's the remainder theorem. Here R is what? R is 1, right? R is your number 1 in this case, right? And then when you evaluate P of R, which is P of 1, then the remainder is 2, which is what they say. The remainder is the value of P of R, is the value of P of 1. More importantly, the more important theorem that I want you to remember or actually understand is the factoring theorem. Again, if I have P of X is a polynomial, then if the remainder is 0, if P of R, if you plug in the remainder and then it turn out the function is go to 0, then X minus R is your factor. It is one of your solution. Making sense, right? So for example, this, don't write this down. So here R will be what? -2, right? -2, yes. R is -2. So if I go for a plug-in, let me plug in P of -2 into the fraction. What happened? Into the numerator. By the way, that's still P. 0, right? It's 0 because it's one of the solution. It's one of the solution. That's what the factor theorem said, right? If you plug it in the remainder and it turned out to be 0, then X minus R is your factor. You'll see it more clearly when I give you an example. Okay? Theory is always kind of abstract until you see the example. So, oh, now see the light. Conversely, if X minus R is a factor, then P of R equals 0. So it's like if and only if statement. Here, what does that mean? Here is they explain more about factor theorem. If you plug in P of R equals to 0, then R is a 0 P of X. It's very helpful later when you try to find the zeros. Later, you can just keep plugging in number. You know what I mean later. So you keep plugging in number. If it gives you 0, it is one of the solution of the polynomial. X minus R is a factor of P of X, and X equal R is the root, or another way of saying root is the solution. Makes sense. Don't write this down. But if I give you this, if X equal 1 is a root, X equal -1 is a root, then when you plug it in into the equation, it's gonna give you what? 0. That's what it said, right? That's what the third bullet point said, right? I know they say they use fancy notation here, but it's everything I told you here that you already know. It's a different way of saying it. Use the remainder theorem to find P of -5. Plug it in. Plug it in. So use the remainder theorem to find P of -5. So here R is -5. Now I have X minus R as my original default formula. So when you plug in R there, X should be what? R minus 5 or R plus 5? Plus 5, right? Plus 5. So minus 5. It's going to be X minus -5 because R is this, use R as black. So that one of your factor is X plus 5. just the FYI, but let's do synthetic division. So R is -5. That means in the box will be -5. And then you bring down all the coefficients. 1, 3, -8, 5, -6. Okay, I don't miss anything. You guys should be pro by now doing this. Bring down the 1 as always. 1 times -5, -5, -2, +10, 2, -10, -5, +25, 19, right? So remainder is 19. So P of -5 equal 19. I'll wait for you to copy that down and I'll explain it to you why I'm doing this. The remainder theorem. What does the remainder theorem say? If the polynomial P of X is divided by X minus R, in this case X plus 5 here, the remainder is the value of P of R. That's what it is, right? The remainder is the value of P of R. Here R is -5. So when you plug in -5, P of -5 equal the remainder, which is 19, right? And how do I get the remainder? Using synthetic division. Right. Here's the question that I asked you if I know that you understand. Question B, is X plus 5 is a factor of P of X? 119. Is X plus 5 is a factor of P of X? Just try it. Try to just think critically. What does it mean to be a factor of P of X? Look at the factor theorem. If X plus 5 is a factor of P of X, then when you divide it by P of X, I'm sorry, when you take P of X divided by X plus 5, what you should get for the remainder? 0, right? 0. So it's one solution, but in this case, it's not, right? So it is not a factor because it's not 0. Right? No, X plus 5 is not a factor of X, P of X, because the remainder. That's all you have to understand about factor theorem, okay? Forget about all those fancy words up there because we're not going to test you on that, right? As long as you understand what does factor theorem mean, I'm okay. And that's all it is. If the remainder is not 0, then it's not a factor. That's it. So this example, they show you the way to factor a polynomial that is not quadratic. So far now, quadratic is special. Why special? Why quadratic is special? So special. Can you always solve quadratic equation, even though you don't know how to factor? Yes, right, the quadratic formula, right? So even though I don't know how to factor the quadratic equation, I still be able to solve it because there is the thing called quadratic formula. However, when you go to degree more than 2, you don't have the formula, special formula, right? So you just have to use different technique. Here is one of them. Given this, my phone goes sleep on me. So highlight, that's my dividend, right? Dividend I highlight in green, and then divisor in yellow. If I want to take that divided by that, well, the first thing first, you're going to use synthetic division, right? The divisor is linear, coefficient of x is 1, use synthetic division. If you don't like synthetic division, you like long division for some reason, you can do that too. So it turned out my quotient is this, and the remainder is 0, which is good. You want remainder to be 0. When the remainder is 0, what does that mean? Is one of the factor, right? It's one of the roots, one of the solution. Now you can rewrite the dividend in terms of what? X minus 6 times the quotient, right? If you distribute that, it gives you back the original dividend, right? Well, like I said, you always know how to solve for a quadratic equation. My favorite is with by factoring. I only do quadratic formula unless I have to. In this case, it is factor. So all you have to do is just factor it out into that. And look at that. From a very, very unfriendly looking function, I can write it in factor form. Which one is better? This one, right? Because when you set it equal to 0, you can solve each of the components. Right? It's just much more friendlier than the green one. So that's how we're gonna do it. We're gonna find the 0, use synthetic division to keep reducing your polynomial, and then just keep reducing until you have factor form. That brings us to problem 6. Do I have my you try? I think you try is on your Moodle already. I don't have to write down. All right, so if you look at the graph right there, it looks like one of those the graph represent the polynomial of the degree, what degree? How many solutions you see there? 4, right? 4, and if they all cross, they all linear. I know it's linear. Remember the last lecture? They all cross, they kind of steep. So it's not gonna be cube here, not gonna fit there. It's gonna be linear. So 1 solution, 2, 3, 4 solutions. So it's gonna be x to the 4, right? It's gonna be a polynomial of degree 4. My first thing is I'm gonna look at the integer solution. I see -2 and 8, 3, saying 8. That's a 3. Right there, -2 and 3. Well, it's good news. I'm gonna use that to do synthetic division. Let me write that x equal -2. I know they use r. I like to use x, so that's your solution. X equal 3. If I add 2, I have x plus 2 equals 0, and then x minus 3 equals 0. This is called zeros. So when you plug it in, the polynomial goes to 0. Makes sense, right? As you look at the graph, at x equal -2 and x equal 3, it's no height, right? It's 0. And this is called factor. So when I say zeros, I meant this. When I say factor, I meant this. I'm gonna use synthetic division. It doesn't matter which one you want to do first, because eventually you have to do both of them. So let's start with the -2. I have 3, -8, -14, 31, and 6. Bring down the 3. Let me use black for the first row. 3 times -2 is -6. -14, +28, +14, -28. Your remainder should be 0. If you're not, something wrong. 31 minus 28 is 3, -6, 0. It should be 0 because x, equal -2 is one of the zero, right? X plus 2 is your factor. So far so good. Right. Now, so now my reduced polynomial will be what? The 3x cubed, right? Or you can write from right to left. So my constant is 3, and then 14x, and then negative 14x squared. This is filling the sign. So that's my reduced polynomial. What does that mean? What does this reduced polynomial mean? Don't write this down. If I multiply that blue one with x plus 2, it should get me back to what? It should get me back to the original equation, right? But I'm not going to do that because I need to keep reducing them into factor form. Keep going. So I'm going to use that reduced polynomial. Now it's going to be 3, negative 14, 14 and 3. And in the box, it's going to be my second zero, which is 3. I know the drill. Just keep doing using synthetic. Negative 5, negative 15. Again, you should have 0 here. Negative 1, negative 3, so 0. If you don't have a 0 for the remainder, something wrong. Now I have another reduced polynomial, which is 3x squared minus 5x minus 1. Now, don't write this down. If I take that blue reduced polynomial, I'm sorry, that's a green polynomial and multiply back to x minus 3 and then x plus 2, it should get me back to the original, right? Because you keep reducing it by dividing, now you multiply back, you should get back to the original. But I'm not gonna do that. All right, I think it's good enough. I think I can deal with the quadratic, right? So I'm gonna start writing in factor form. So your semi-final step is gonna be, I'm gonna say now we can start writing in factor form. So factor form is gonna be, doesn't matter the order, x plus 2 times x minus 3 times 3x squared minus 5x minus 1 equals 0. Can you break it down the quadratic factor? Yes, right, using quadratic formula or factoring. In this case, I don't think you can factor because I cannot find two number multiplied to be -3 and add to -5. Impossible. Yeah. So it's gonna be an irrational solution. So quadratic formula. Up here. You know better yet. Sorry, you can do that with the paper, but I can. Alright. So I'm gonna go down here so I have more room. Let me rewrite this. 3x squared minus 5x minus 1 equals 0. And then quadratic formula will be x. Can someone remind me what's the quadratic formula? Very good. what I see people do on the exam is this. You got everything right, except for the for the horizontal line. You only put it over here, and you forgot like, oh, B is not divided by 2A, but you may want to cover the whole thing. I always do that because I make mistakes. If you want to be more careful, you can do more steps. So I see A is 3, B is -5, and C is -1. Let's plug it in. -5, -5, 3, -1, 3. +5 plus minus. I don't feel like keep rewriting things, so I'm going to simplify the one in green there. This one equal to what? 25 plus 12, right? That's 37. So root 37. Over 6. And that's your x, right? So what are your zero? That's what, so your final answer my zero that I see from the graph is x equal -2 and x equal 3. And my other two zero that I have to use synthetic division to figure it out is x equal 5 minus root 37 divided by 6, and x equal 5 plus root 37 divided by 6. It makes sense, right? 4-degree polynomials, you should have 4 solutions. In this case, all your solutions are reals. Why I say reals, I mean maybe there's complex solution next lecture, not this one. So far, so good. All the little baby steps I'm showing you here is for the exams, right? Usually, here is, if you notice, here is what happened. Like the first 4 pages is the little baby step that kind of lead you toward to the final, like ultimate problems, right? That you use all the little baby steps just to finish the problem. Here is another theorem called rational zero theorem. It's pretty straightforward. Given the polynomial right there, P of x, I don't have to read it for you, where an is your leading coefficient, right? And a sub naught is your constant. Then the form P over Q, what is P and what is Q? P is a factor of a naught, of your constant. So let me highlight here the leading coefficient. I'll highlight in green the leading coefficient, usually integer. And then there's a naught. I highlight in blue. So P is a factor of a constant term a sub naught. And Q is a factor of leading term an. What does that mean? I'll explain it to you. Do not worry. For problem A, let's identify what is a naught and what is an. Here's my constant will be what? 6, right? What are the factor of 6? Yes, think that divide 6, right? 1 divide 6, 2, you're gonna consider the negative case too. So factor of 6 will be plus minus 1, yes. Plus minus 2, plus minus 3, and plus minus 6. By the way, in mathematics, if I say 6 divided by 2, it's the same thing as 2 divide 6. Right? With the big number, you use passive tens, I guess, in English. We say 6 is divided by 2, but then if the smaller divided by the bigger, we say 2 divides 6. It's the same thing. So they both equal 3. And AN will be, what's my leading coefficient? 2, right? And then you do factor of 2 things that divides 2. Well, numbers that divide 2 will be plus minus 1 and plus minus 2. That's what they meant by factors. Now you're gonna write in, you're gonna put it in, so that is my P, and that is my little Q. Now, P divided by Q. Keep it in mind, you don't want to write redundant here. P is what? P is P right there. So P divided by Q. Let's do one pair at a time. So plus minus 1 divided by plus minus 1 equal plus minus 1. So 1 divided by 1 is 1, but 1 divided by negative 1 is negative 1. Right? So so you're gonna take care of that too. So it'll be plus minus 1. And plus minus 1 for the top divided by plus minus 2 will be plus minus 1/2. Oh, always add the plus minus, okay? It's just, yeah. All right, we're done. We're done with the 1. Now go to the 2. Plus minus 2 on the top divided by plus minus 1 on the bottom. Plus minus 2. When you say 2, I assume you write plus minus 2. Plus minus 2 on the top divided by plus minus 2 on the bottom is plus minus 1. We already have it. I'm not going to rewrite it. Right, so we're done. Plus minus 3 divided by plus minus 1 is plus minus 3. Plus minus 3 on the top divided by plus minus 2 on the bottom. Plus minus 3/2. And then we're done with the 3. Plus minus 6 divided by plus minus 1 on the bottom. Plus minus 6. And then plus minus 6 on the top divided by plus minus 2 on the bottom. 3, which we already have. So that's all your possible 0, your candidates. Your candidates. A few of those going to be your real 0. You just don't know which one, right? Good news for you, I'm going to do it my way. So forget about that. I like to keep it short and sweet. It's similar to what they show you here. It's just shorter. Okay, just shorter. Right, so let's go ahead and do this one. Number 10. And I'll write out the step, my step too. Okay. All right, here is something you see on your exams. Your ultimate problem. So step number 1, you're gonna list all possible 0. List all possible candidates, possible 0s using factor of P, factor of A naught divided by factor of N, which is P divided by Q. Let me remind what P is and Q. So P is a factor of your constant term, and Q is the factors of the leading term. In this example, A naught is -1, AN is 2. So factor of -1 is plus minus 1. Always add plus minus to worry about. And then factor of AN is plus minus 1, plus minus 2. Now, P over Q, one pair at a time. Plus minus 1 divided by plus minus 1 is plus minus 1. Plus minus 1 divided by plus minus 2 is plus minus 1/2. And that's it. Short one. Short one. That's step number 1. Step number 2. See, it's 5 points just doing that. You live on partial credit, so do not leave your thing unwritten, right? Just whatever you think in your head, write out. Maybe I'll give you partial credit. Step number 2, you can evaluate a few integer. two integer. To see if P of R is equal 0. If it's 0, then it is your solution, right? It's when it's 0. This implies then R is your 0. My favorite integer, usually I start with either -1 or +1. Hint. Start with either +1 or -1. First, right? I'm not saying that you stop right there. First. Wait for you to write those down. Now, let's start with 1. Don't write it down. I want P to turn out to be 0. If you look at the function, if you plug in 1 there, is there any way you're going to end up 0? No, right? It's too big. So I'm going to start with -1, right? So just by common sense. So the 1 look like it doesn't work. So -1. I'll write out for you just for the sake of the note. You want to write this step, you don't have to. But on the exam, I just recommend you write everything out. If you make a mistake, I can give you partial credit. We give you a happy ending without using the calculator. It is 0. So what does that mean? It is one of your 0, right? 0. Let's do one more. Let's do one more. All right, we only have 2 options here. Oh, 4 options. We eliminate the 1 and -1. Now the positive half and negative half. If you plug in a half into the function here, you think you can end up 0? No, right? Likely not. So we will start with the negative half. We start with the negative half. You can try. There's nothing wrong with not trying. Just and if you use your calculator, it did turn out to be 0. So yay! 2. Usually 2 is enough because this is the polynomial of degree 4. So you got 2. Your leftover will be quadratic, right? So you're okay. So we're gonna start right here. Your next step will be using synthetic division. To try the rest 0. We almost done. Our last problem here. Let's start with the -1. And then write out the original coefficient of original problem, so which is 2, 13, 4, -1. 15 or no, 15, 15, thank you, 15. My note is wrong then. Thank you. Bring down the 2, -2, 13, -13, -9. Something wrong? Did I miss something? 15, 17. Oh, sorry. 15, sorry, I look at the wrong one in my note. 2, sorry about that. 2, 15, 17, and then 3. Sorry about that. I look at the wrong one in the note. 1. Read it again. 2, -2, positive 13, negative 13, 4, negative 4, negative 1, 2, negative 2, which is positive 13, negative 13, which is positive 4, the negative 1 here, positive 1, so 0. It should be 0. So that's right there. That's your reduced polynomial, right? It would be 2x cubed plus 13x squared plus 4x minus 1. Now you keep going. Now you keep going. 2, 13, 4, negative 1. And then in the box, you put in the second 0, which is negative half. Two, negative half times 2 is negative 1. And then I have 12. Negative half times 12 is negative 6. Negative 2 times negative half is positive 1, 0. Can I divide both side by 2? Can I divide both side by 2? Yes, right. You don't have to, but it's just make your job easier in terms of computation. So x squared plus 6x minus 1 equals 0. Again, this one is not factorable, so we're gonna use the quadratic formula. X equal negative b, which is negative 6, plus minus b squared, so 6 squared, minus 4 times 1 times negative 1 over 2 times 1. Don't tell me it didn't save. Please save. It didn't save. But you guys got it down. You know, I'm gonna continue with my quadratic formula because I'm running out of time. So I have negative 6 plus minus square root of 10 over. All right, I'll fill out when I'm home and I'll post it on Moodle. Can I factor out the 2? And then you cancel the 2. So you have x equal negative 3 plus minus square root of 10. And don't forget to write out other two 0, which is what? X equal negative 1 and x equal negative 1/2. Then you're done. So okay. Have a good one. On Wednesday, I'll talk about a little bit more about exam 1. And then Friday, you have exam 1.